Okay, hello everyone. My name is Eric Ilote, a student of CIS 610. So my project was about car price prediction and visualization. So in this presentation, I'll cover 5 areas. That is introduction to the problem, methods used, conclusions and outcomes, future work, and the hardest and interesting experiences that I had in the project. So let's dive into it. So predicting and visualizing car prices. The major problem, as already said, is predicting the car prices and visualizing the prices. And this problem can be solved by creation of a regression model to predict the car prices, and then to visualize the most common indicators of prices using a Tableau. Next, the method used. So like I've already said, regression is a method that was used to determine the statistical relationship between a dependent variable, which is price, and other independent variables. Then the data that I used was from the Cargo website. And so I've already said the price was the dependent variable, and independent variables included variables such as compression ratio, horsepower, engine size, carb weight, stroke, and wheelbase, among others. Still on method used, the first thing that you have to do when you are building a regression model to predict something, you have to clean up the data first. So I did what we call data wrangling or data merging or data cleansing using tools such as Python and SPSS. Python was used to detect outliers, to drop null values, to correct misspelled words, and to delete duplicates. And then I used SPSS as a software to detect multicollinearity and variance inflation factors. This slide I talk about data cleansing, especially multicollinearity and variance inflation factors. When you have like 2 or more independent variables that are highly correlated, then you'll not get a good result in creating your regression model. For example, here we can see that carb weight, city miles per gallon, and highway miles per gallon, they are highly correlated, and therefore they can have an impact on regression results. Therefore, we have to eliminate such variable. And if you look this side, you'll find that I managed to eliminate those variables that are highly correlated from my analysis. Still on the method used, I decided to find out which variables are highly significant or are significant in predicting car prices. Those are independent variables. And when you look at this table, you can see variables such as wheelbase, car width, compression ratio, stroke, horsepower, and the city miles per gallon are some of the variables that are very highly significant when predicting car prices. Next, I decided to build now the model using Python, the model to predict car prices, and what I did was to split the data into the train and the test portion first, then build the model using the scikit-learn package, where I was pulling the regression method from the package called scikit-learn, and then I cross-validated the model, and then finally I built a function to predict car prices based on compression ratio, horsepower, and wheelbase. Perhaps I can show you my code on how I did that. So when you look here, you can see the code I used, and here you can see I am importing the scikit-learn package, and then I'm building the regression model. After splitting the data sets into train and test, I built the regression model. The model had an accuracy of 0.79.58 to 2 decimal places, or you can say 79.5%. Then I cross-validated the model, and finally I built a function to predict car prices only using 3 variables. I decided to use compression ratio, horsepower, and wheelbase. And here you can see now we can be able to predict the car prices. For example, here you have the Toyota. We can manipulate this and perhaps put the compression ratio of 35, maybe the horsepower of 450, and we can leave the wheelbase to be 95. And when we run this, you get the price here. So you are able to manipulate and predict car prices. Back to our presentation. So like we had said, I managed to build the model and build a function to predict the car prices. And then finally, after building the model, I decided to create an interface or a website to which users can get on the website and use it, key in the figures, and they will be able to predict the car prices. So I used tools such as Python, especially the PyCharm IDE, to build to create a Flask server, or to build a Flask server. And then I used another IDE, Visual Studio Code, to create the HTML, which was to run the interface of the website, and then CSS to style the HTML, and finally the JavaScript, which I used to load the data in the background. And we can go there and see this. If we go here, because the server is running on my machine, the interface, can just type in here localhost, and then when you run, you'll get this is the interface that I managed to build, and you can put here the horsepower, whichever you want, maybe manipulate it to 450. Compression ratio, you can put it at 30 perhaps, at 30. Then the wheelbase, you can leave it at 95. Then we can choose a car like a Nissan, and we are able to estimate the price we get. That is $17,712.5. Or we can decide to try another model, maybe 600 horsepower, compression ratio of 35, wheelbase of 90, and then we get a car like a Toyota, and we are able to estimate the price of that car. Back to the presentation again. The next, I looked at visualization now using Tableau, and I was able to visualize car types in numbers, common cylinder number, car body by price, and cab weight. And we can see here, if we go to Tableau, we're able to see what I created in Tableau. Perhaps if I able to expand it more here, and we can see the type of cars, the all type of cars. Then here we can see the cylinders, and the most common type of cylinder is the 4-cylinder. Then here we are able to see car body and the price, and sedan is one of the more expensive cars, and then followed by the hatchback and all others. Then finally here we have the cab weight versus the price, and you can see as the cab weight increases on this scatter plot, as the cab weight increases, so the price also increases. And because I created this dashboard in a way that you can visualize each individual car, you can look at a Toyota, you'll see all things that are all graphs that are related to Toyota, or you can choose a Mazda and you'll see the information about Mazda, Mitsubishi, Nissan, and so forth. Going back to our presentation. Next on future work. On future work, perhaps it will be possible to spin up an EC2 instance. For example, you can spin up Ubuntu or Red Hat on AWS, and then install on it the Nginx or Apache web server. And then we can be able to deploy the model that we've created on the EC2 instance on the cloud, so that when you are able to buy a domain name, people can visit the website and be able to use it to predict car prices. The hardest and interesting experience throughout the project, the hardest part was creating the UI or the website using the HTML, CSS, and Java to enable people to key in those figures and be able to predict car prices. Then the interesting part was creating the prediction model itself using the Python. Thank you for tuning in. Looking forward to your questions after watching the video. Thank you.